Next up is the third basic rule of differentiation, which will be the linear combination rule. Linear combination rule. This rule tells you how to find the derivative of a f of x plus b g of x, where a and b are real numbers. So a and b are real numbers. This symbol right there just means is an element of or is contained in the set, and this symbol means a set of real numbers. So taken all together, this says a and b are elements in the set of real numbers. And this is called a linear combination of f and g. Just multiply f and g by coefficients and take their sum. And the derivative of that is actually really straightforward. It's just a f prime plus b g prime. So af plus bg differentiates to af prime plus bg prime for real numbers a and b. The proof of this we'll use the limit definition for. So we start with the derivative of a times f plus b times g. We then use limit notation to express the derivative. So the limit as delta x goes to 0 of the function when you plug in x plus delta x. So when we plug in x plus delta x, it gives us this into our function, minus just the function when you plug x into it. So that's a f of x plus b g f of x. I said that incorrectly. It's just a f of x plus b g of x, all divided by the change in x. So it looks weird, but that is the function, which is this whole thing up here, when you plug in x plus delta x, and the function when you just plug in x. And all the proof is just a clever rearrangement of your terms. We're just going to group our f terms with each other. So we have the limit as delta x approaches 0. When I group all of my f terms, I have a f of x plus delta x minus the a f of x, and we'll make that into its own fraction. Plus, I'll group all the g terms. So that's b times g x plus delta x minus b times g of x all over delta x. And we can express each as their own fraction, because when you add up your fractions, you keep the denominator the same. So that breaks apart into this. We learned in lecture 1 that the limit of a sum of two terms is the limit of each piece. So we have the limit of just our f terms plus the limit of our g terms and we also learned from lecture 1 that you can factor constants outside of limits. So a does not depend on delta x, therefore it's constant, and you can factor that outside of the limit. And the same thing happens with our second limit. We can factor b, which also does not depend on delta x, so therefore it's constant, and we can factor it outside of the limit. And now we have our answer, because we have a times this limit. We know this limit's f prime. That is the definition of f prime. Plus b times this limit, we know this limit is g prime. And so we have our result. A lot of proofs are kind of like this, just cleverly rearranging all of the terms until you get forms that you can write and how you want to write them. Notice, by the way, that if b was 0, this just says that the derivative of a times f of x is a times f prime.